Okay, now we're going to be looking at the second part of the formulas and equations topic. So now we're going to look at these 3 dot points, and then in another video, I will finish off this topic. So the first dot point as part of the blood alcohol content section is to apply the formulas for blood alcohol content for males and for females. So they're both given there. And then using those formulas, to calculate and interpret what it means, and the blood alcohol content, based on drink consumption and body weight, where N is the number of standard drinks, H is the number of hours, and M is the person's weight in kilograms. So the very first thing I want you to notice about this formula, BAC, I'll just write the male one for now, 10N minus 7.5H over 6.8M, is the bigger that this thing gets on the top of the fraction, so the bigger your numerator gets, the bigger your BAC value will get. However, the bigger your denominator gets, the smaller your BAC will get, because they are inversely related, whereas the BAC and your numerator, they're directly related. And that's not just for this formula, that's for any formula. If you've got any formula equal to a fraction, an increase in the numerator of the fraction will always increase the thing on the left, and an increase in the denominator will actually decrease the thing on the left. So you can see that if your mass increases, that's going to increase your denominator of your fraction, which is going to, in turn, reduce your BAC, which makes sense. If you're a bigger person, you're heavier, you're going to have a lower BAC if you drink the same amount of alcohol as a smaller person, and the reverse is true. However, your numerator, the larger that gets, then the larger your BAC gets. So say you have a lot of drinks, you do 10 multiplied by N. You've got a lot of drinks, so 10N is going to be big. And let's say you only have that over a very small period of time, like 1 or 2 hours. Then this negative 7.5H, you're only going to be minusing a small thing off this 10N. So the whole numerator is still going to be really large. And since that's directly related to your BAC, that's going to increase it. So I just want you to get that understanding of how the variables directly influence BAC. I want you to understand that. Next dot point is to apply the formula time is equal to your blood alcohol content divided by 0.015. That's to estimate the number of hours required for a person to stop consuming alcohol in order to reach 0 blood alcohol content again. It's pretty straightforward. And then finally, identify some limitations of this method, okay? Why might it not be that useful, and so on, okay? So we're going to do a few practice questions on each of these dot points. So if we start off with the first one here, very simple. You're just plugging numbers into a formula. So the first is to calculate the blood alcohol content of a male who weighs 80 kilograms and drank 7 standard drinks over 3 hours. So that's exactly what we're going to do. So our formula is BAC for male is equal to 10N minus 7.5H over 6.8M. So for N, we've got our standard drinks, which is 7. So we're going to get 10 times 7 minus 7.5 times the number of hours, which is 3. And all of that is going to be divided by the mass times 6.8, or 6.8 times the mass. Okay, and if we work that out, if we type that into our calculator, that's going to be approximately equal to 0.0873 if we round. So that is the male's blood alcohol content. Now for the same numbers, we're going to use the female blood alcohol content formula. Now just without even calculating yet, you should be able to determine whether our blood alcohol content for females will be smaller or larger than for males. And the way we're going to do that is using the theory I just explained at the start. So for the female formula, the numerator is the same, but the denominator is 5.5M compared to 6.8M. So since we've got a smaller coefficient of M on the bottom of the fraction, our whole denominator is going to be smaller for the female case. And if the denominator is smaller, then the blood alcohol content is actually going to get larger. They move in opposite directions. If one's bigger, the other's got to be smaller. Unlike the blood alcohol content and the numerator, where they go in the same direction. Where when the numerator increases, so does the other, and then vice versa. When one decreases, the other does as well. So we can expect our denominator to be smaller for the female case, which will make our blood alcohol content larger. So we should be getting a number larger than 0.0873. So let's verify that. So BAC female is going to be exactly same numerator and almost the same denominator as well. We're just changing that 6.8 to a 5.5. We're just changing the coefficient of that m there, and we're going to get 0.108, which is true. That is larger than the blood alcohol content of a male. Okay, so that's all that's involved with that formula. Very straightforward. Next, apply the formula time equals BAC over 0.015 to determine the number of hours required for a person to stop consuming alcohol in order to reach zero blood alcohol content again. So, using our result from the previous male BAC value, calculate how many hours it will take to return to zero. So, from our previous question, we had a BAC of male is equal to 0.0873, and that if he stops drinking alcohol now, the time required for his blood alcohol content to drop to zero will be whatever his blood alcohol content is currently divided by 0.015. And if you work out that, that's going to be approximately 5.82 hours. And if you wanted to convert that to minutes, it's got to be about 5 hours and, sorry, the 0.82 hours to minutes. That's going to be approximately equal to about 49 minutes. So there's nothing more complicated than that. There's only one unknown to work out the time for your blood alcohol content to reach zero, and that's what your current blood alcohol content is. And then we move to the last dot point, identify some limitations of the method. So it should just be common sense that if you've got a blood alcohol content of that, it's not going to be the exact same amount of time for every person to reach a blood alcohol content back down to zero. And that's due to a number of factors, such as whether you've eaten, so food consumption can make a difference, someone's metabolism, and how well their organs are, their liver, and etc. It's also got to do with female versus male body sizes. So, for example, if you use the female formula for like a large female who's similar in size to a male, well, then it's not going to be very accurate because the female formula assumes for smaller or lighter human beings, as females are typically lighter weight than men, and vice versa. You could have a particularly smaller male who's more in similar size to a female, but if you use the male formula for him, it's not going to be that accurate. So there's a bunch of factors there which will affect it. So I'll just write that one down as well. So we've got female versus male sizes, because the formulas are different, but they might not always be 100% for every gender. And yeah, I think that's about it. There's a bunch of other factors as well, but like all models, there's always limitations, and it's never going to be 100% accurate. It just is always going to give a good indication. So that wraps up today's video. I will finish off the formulas and equations topic in the next video. Thank you.